Hello, my name is Mr. Lee, and I will be explaining basic trigonometry as quickly as possible so that you can get done with your homework as quickly as possible. Before we dive into the meat and bones of everything here, it is first worth defining just what trigonometry is. Essentially, trigonometry is a branch of mathematics concerning the sides and angles of triangles. What does this mean? Well, firstly, let's look at our sample problem, and I will explain as we go along. Okay, so this is our sample problem right here. So the problem is a person is standing 7 meters away from a tall building. If the person looks up at a 50-degree angle to meet the roof of the building, how tall would the building be? So already the keen-eyed will know that we are essentially solving for a variable in this problem, just like we would in algebra. So that variable being the overall height of the building. But how exactly do we find this variable that we shall call from here on out x? Let's dig into some vocabulary before we move along. Firstly, it is important to know what angle is being used. In this problem, we are viewing from the perspective of a person who is sitting at ground level and looking at the roof of a building. Relative to this person, all right, this side of the triangle will be known as the adjacent, all right? And this side right here will be called the hypotenuse, right? I messed it up a little bit. And right here, where the variable is and the side of the building, this will be known as the opposite side. Now, for reference, if we were to shift the perspective of the person who is standing at the bottom of the building right here at the ground level, let's say that this person was instead up here, standing at the top of the building and looking down at the ground. That would mean that the opposite and the adjacent would change while the hypotenuse remain the same. The hypotenuse will always be projected out from the 90-degree angle formed from the building. But the opposite would be moved over here and the adjacent would be moved over here because that means that the opposite of the perspective would be right here and this side would be touching or be adjacent to the new perspective that we put on top of the building right here. To help us out in determining the answer to this problem, we have three mathematical functions that will help us out. These functions are called sine, cosine, and tangent. If you look at the face of your calculator, you will notice that the first three letters of each of these terms right here, these functions, will be sin, cos, and tan. That's what it is on the calculator. But what exactly do these three functions mean? Well, if you take sine, sine equals the opposite over the hypotenuse. Cosine equals the adjacent over the hypotenuse. And lastly, tangent equals the opposite over the adjacent. These three functions and what they equal can be a bit difficult to remember at times. However, there is an abbreviation that a lot of students, and even myself, heavily rely upon to actually remember exactly what these functions represent. That would be SO, CA, TOA. If you look at the abbreviation SOCA TOA, you would see that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. The first letter of these three abbreviations corresponds to the function, while the following two letters represent the sides of the triangles that are being used in order to execute the function. When building and constructing the triangle for this problem, we are given an angle and a side, that angle being 50 degrees and that side being 7 meters. With this, we will have enough to solve for the problem. But how do we know what function to use? When looking at our SOHCAHTOA abbreviation, we need to find a function that includes both the side that we need to solve for and a given side. Tangent is perfect for this example because we are solving for the opposite side of the triangle by using a given adjacent side. All right, so when we plug this in, we will get tangent, and we take the angle that right here, the angle of the perspective of the person standing on the ground looking up at the top of the building. That's where we put the 50 degrees. We put it in the parentheses right after the tangent function. All right, so tangent 50 degrees equals, and then we take the opposite, which is our variable, and we put x over, and then we put 7 meters. All right, so from here, we do basic algebra in order to solve for this. So what we do to one side, we need to do to the other, and we need to separate the variable from any constant that we have so that we can solve for the equation. So how are we going to do that? Well, we need to take times 7 on this side and times 7 on that side. 7 times tangent 50 degrees equals x. Now, when you plug this into your calculator, you should get x equals 8.342 meters. Now, it should be worth noting that I was using degrees with my calculations rather than radians. This is set to be the default for most calculators, but if I'm not mistaken, the TI-84s used in most high school classrooms will be set to radians by default, so make sure you have the setting checked out before you continue solving. All right, so once you solve for this side of the equation, you will get the answer of 8.342 meters tall. And that is how tall the building is. And that is how far away the person is standing away from the building, looking up to the top of the building. And that, in a nutshell, is very, very basic trigonometry. I hope you guys learned something.